Brilliant. Thank you very much, Simon. Good morning and welcome. My name's Steffan Eldred. I hope you enjoyed that quick video. If anything, it saves a bit of speaking time for me and saves me having to do the KTN sales pitch. So just the first thing on practicalities I just mentioned quickly is that this is being recorded. Okay, so this will be recorded and my colleague Shelley will share this after the event. So, as I say, welcome to the Innovation Network launch. I'm Knowledge Transfer Manager in the Clean Energy and Infrastructure team, and also the Hydrogen Lead. We're also joined by my colleague Simon Buckley, who focuses on low emission mobility, but is also helping lead the Innovation Network. He's driving these slides in the background, so you probably can't see him for now, but he'll be showing his face shortly for some questions. And also we've got my colleague Shelley, who is from our events team, but is looking after things from a technical point of view. So you'll all be muted throughout the webinar. There is a Q&A box for submitting any questions. We'll hopefully have a couple of opportunities for Q&A if we get time. Use the chat function for any discussions with other delegates and any panelists. As I've mentioned, Shelley's online, so any technical issues, please direct them to Shelley. I've mentioned about it being recorded. We'll also we'll share slides with you after the event as well, so there's no need to be scribbling down those notes or taking screenshots or what have you. A key thing is something called Meeting Mojo. So obviously we'd all dearly love to all be in the same room so that we could catch up over coffee, catch up after the event and keep the conversation flowing. Alas, we can't do that, but Meeting Mojo isn't a bad second option. So when the joining instruction came out, there would have been a registration link for Mojo. So you're strongly encouraged to register on that. And from 1 to 3 this afternoon, there will be the option to have meetings with other delegates, people like myself, Simon, and what have you. So it's a good way of carrying on the conversation. It's also worth saying before the event, 319 delegates were already registered onto that. So it is a great networking opportunity. Next slide, please, Simon. So just very quickly, in terms of the agenda, we're pretty jam-packed agenda and we do have a hard stop at 11:30 for a couple of reasons. So I'll try not to take up too much time. In a second, we'll move over to Rita from BEIS and hopefully we'll get a chance just for a quick couple of minutes Q&A before Rita has to disappear. We're then going to use something called Mentimeter so that we can have a bit of interaction and some live questions from all of those joining us. Rebecca from EDF will then be talking about high for fleets, Julian talking about aviation, Matt Candy from Steamology, and then something a bit different, we've got Nopi from British Antarctic Survey talking about the challenges that they face. And then obviously I better tell you what this is all about, what the network's all about. And we will, as I say, we'll try and get some time for Q&A at the end. We'll try and keep it as tight as we can. So on that basis, I'd better stop talking myself and hand straight over to Rita. Good morning, Rita.
Good morning. Thank you, Steffan. Apologies that I really need to get a better light shade above my head because I'm glowing slightly this morning. Thank you very much for the invitation to attend this event. It's great to see so many people here so early in the year. What I'm going to do today, if we move on to the first slide with what I will cover today, Simon, I'm going to give an overview of the latest developments from a hydrogen strategy and policy point of view. I'm the Deputy Director for the Hydrogen Economy in BEIS, and I'm responsible for developing, pulling together, I should say, the first UK hydrogen strategy and have responsibility for hydrogen production and coordinating all the activity that's going on in many other parts of government as hydrogen is increasingly mainstreamed, including with my innovation colleagues within BEIS and in UKRI. I know that there's an awful lot of innovation activity that's being funded from government and from a range of other funders, and I'm not going to seek to cover that today. I'm really going to look at the macro context because that's sort of where we're all working today, and quite a lot have happened late last year, so it'd be good to give an overview of the way that we are seeing the world. So if we move on to the next slide. So the UK context, many of you will be familiar with this. Heat really began the conversation for the UK, but net zero brought it into the mainstream. We've seen, people talk about hydrogen hype cycles. I'm still hearing that being discussed now. I had a meeting with some international colleagues before Christmas where that came up. Does it feel different this time? In the UK and internationally, the consensus is yes, but I think there's certainly a long way to go before the UK hydrogen economy is scaling up and decarbonising and entering other sectors, or we're seeing the development of an international hydrogen market. But we do see that hydrogen is critical to meeting net zero as a complement and an enabler to a deeply renewable, deeply decarbonised system, and it can reduce the cost of 2050 system costs of 2050 scenarios. We think the UK is really well positioned, both from a production and a demand point of view. Our geography, our geology, the institutional arrangements, the scientific base that we have got specific advantages, and we have the potential to use hydrogen in a number of areas across the economy because of the way that we use gas today, and moving to having a decarbonised gas in the energy system will be very valuable. There's a lot of ranges being talked about what the possible demand might look like in 2050. We can't know that at this point, but we do know that we're currently looking at between 10 and 27 terawatt hours of hydrogen, which is for the greater part not low carbon. So we need to scale up and have a complete switch to low carbon. Moving on to the next slide. I just wanted to talk about hydrogen in the government's 10-point plan for a green industrial revolution. This, you will have seen, was announced by the Prime Minister in November of last year, I think it was now. And in that, we set out an ambition to work with industry to have 5 gigawatts of low carbon production capacity for use across the economy by 2030. And we're looking to get to kind of 1 gigawatt by 2025. So that sets out that we are looking for that scale up at this point. We were lucky enough to get some capital co-investment funding of 240 million out to 24-25 for a net zero hydrogen fund. That is for deployment. I'll talk a bit more about some of this later. It confirmed that we're going to publish the hydrogen strategy. It talked about the need to provide ongoing revenue support for hydrogen production. It talked about moving forward with our hydrogen for heating investigations to villages and towns across the decade, and it confirmed that hydrogen would be a priority area for the Net Zero Innovation Fund. Moving on to the next slide. Back in September now, the former Secretary of State, Alok Sharma, committed to publish a UK hydrogen strategy. And we've confirmed that in the 10-point plan and in the energy white paper. That will be a whole system strategy. It will look at supply through to demand across the whole value chain. It will talk about why hydrogen makes sense in the UK context. We want that to be a whole UK view. We know that in each of the nations, work is ongoing and to develop their own hydrogen plans, but we want to be able to showcase the whole of the UK in a UK strategy. The focus will largely be on the action that's required in the 2020s to meet that 2030 ambition, but we want to be aware of where we need to lay the groundwork for the ramp up beyond 2030, which will need to be pretty steep. One thing we think we have an advantage of is because we are at the early stages of developing the policy and strategy for hydrogen, we can make sure that we're building in a focus on the economic benefits from the very beginning. We want to be clear on the role of various actors in this, because it's not something that just government can do. Government at all levels needs to be involved. There's a role for the R&D and the innovation community, for industry, regulators, a number of different players. On the next slide, just to talk a little bit more about production, even though our interest is more broadly, just as we're not thinking about electricity or hydrogen, we're not thinking about CCUS-enabled blue hydrogen or electrolytic renewable hydrogen, green hydrogen. We want to focus on both. We believe that in order to get low carbon hydrogen at scale in the 2020s, with the kind of volume that is going to drive investment in networks, in end use activity, particularly things like industry, where even the testing requires quite significant volumes of hydrogen to to commercialize the kinds of boilers and kilns that you might need in an industrial setting. We need volume, and blue hydrogen can provide that. But in the meantime, we want to be scaling up the green hydrogen industry in the UK, recognizing that that is where hydrogen will move to in the longer term globally, and that we have strengths there. We've got electrochemical strengths, we've got a lot of renewable potential, so we want to be growing green hydrogen alongside. That approach is has been informing our innovation. The BEIS Energy Innovation Programme has supported both blue and green projects. That should say the Net Zero Hydrogen Fund, which is the new expanded fund from the Low Carbon Hydrogen Fund. It's also funding supporting business model and strategy development. And we're calling this the twin track approach. In the last year, we set up a Hydrogen Advisory Council, which brings together a number of CEOs from various companies with hydrogen interest in the UK. That's co-chaired by now Secretary of State Kwarteng, so we need to work out how that's going to work going forward, and Sinead Lynch from Shell. That's met 3 times now. We're meeting again in another couple of weeks. That is going to inform the development of the hydrogen strategy, and also its early implementation, because it runs for 2 years. And it's a complement to a number of other government industry groups on the heat development, heat programme development, on CCUS, on Jet Zero, on offshore wind. And underneath that, we have established a number of working groups, and this is where we want to do some co-creation with external partners, and those groups are just getting underway, apart from the one on R&D and innovation, which is yet to be firmed up, but it's something that I'm talking to Paul Monks, who is our new Chief Scientific Advisor about, and how we can really bring together funders and users and think about what the innovation priorities for the next few years are going to be in support of the ambition and that further scale up beyond 2030. So that's something we'll be doing some more thinking about in coming weeks. So here's quite a busy slide on the funding landscape, which isn't even fully up to date. So this is just showing some of the things that have been funded under the BEIS Energy Innovation Programme and some of the big Ofgem funded programmes across the value chain, where we've supported hydrogen supply projects like HyNet in the northwest, looking at blue hydrogen, and the Gigastack project, which is looking to scale up electrolytic hydrogen. Looking at Hy4Heat, that programme has seen the development of the first hydrogen-ready boilers, and is looking at the safety testing that would be required for 100% use of hydrogen. There's been some deployment activity happening from transport, and DfT have also received funding in the spending review to look at innovation. They're funding a hydrogen transport innovation hub in Teesside. They're looking at marine innovation, innovation for zero emission HGVs that can include hydrogen. And over there's a CCS infrastructure fund of £1 billion out to 24-25, which will enable some of the blue hydrogen production that I was talking about earlier, but also the deployment we'll see under the Net Zero Hydrogen Fund the deployment of green hydrogen. And then within that as well, the BEIS Net Zero Innovation Fund, the successor to the Energy Innovation Fund, which has got a £1 billion budget, and as confirmed in the 10-point plan, that will continue to support hydrogen, and details of what the competitions under that fund will be coming out in coming weeks and months. One thing we're going to do, I'm very keen to do with the Hydrogen Advisory Council R&D and Innovation group, is get a much better sense of what the funding landscape looks like, so that we can support all of you by helping people be aware of the funds that are available and how they fit together, because sometimes that can be quite complex, what the handoff point is between certain types of funds who are funding things at certain TRL levels, and then where those kinds of projects would get picked up later on. So hopefully that's something that we will be able to talk about a bit more in the strategy when that comes out in early this year. I can't believe it's this year now. And then finally, just to talk about next steps. So the HAC working groups I mentioned are getting underway. We've got one today on the roadmap to 2030, and the R&D and innovation one, getting that staffed up and in place is certainly a priority. We'll be engaging on the design of the various funds that come out, not just the Net Zero Hydrogen Fund, but we'll be working alongside our innovation colleagues on the priorities for the innovation funding. And also the other deployment funds. We'll be working on our strategy development ahead of publication, and there'll be a consultation on the hydrogen business models alongside the strategy. So it's going to be an extremely busy few months ahead. This is my second day back from leave and it already feels extremely busy, but I think that's a signal of just how far we came last year with hydrogen really getting high up on the political agenda. Our Kwasi Kwarteng, who's our new Secretary of State, is a massive supporter of hydrogen, and I know that that is shared in number 10 and increasingly in other ministers' portfolios. So that's a really exciting thing to see it being mainstreamed. And now if we can bring all of that together for the hydrogen strategy, hopefully that will set us out on a really good path for the 2020s. So my contact details are there and you'll see these slides afterwards. And that's it from me. Thank you.
That's great. Thank you very much, Rita. It won't surprise you to know that we've had quite a few questions.
Yes, I can imagine.
But we've only got about, I know we've only got a few minutes, both from your side and from our side, to be honest, with a packed agenda. So let me just pick and choose a couple. I suppose just starting off, just a question about standards. So do you have a view on what role you think the government will play in setting hydrogen standards? So I suppose both, you know, getting the volume into the grid, a safety point of view, that side, I guess it's quite a high priority. Yeah,
so there's a lot of activity going on. I mean, there's some work happening from my team on a low carbon hydrogen standard, where we are looking at sort of life cycle analysis of the production techniques, so that we can make sure that we're incentivizing the right kind of hydrogen, as it were, because we want to be thinking about a pathway to net zero, and that will then, in that standard and that development, which we've got some research activity happening on that at the moment, the E4 Tech are leading for us, and that will come to the standards of regulation group, and we'll talk, there'll be some consultation on that later in the year, and that will inform the way that government allocates funding in the Net Zero Hydrogen Fund and the way that we allocate business model funding as well. Then there's work going on sort of safety standards in each of the end use sectors. There's activity going on across BEIS and HSE on things like the blending into the grid and the work on the hydrogen development programme for 100%. So it's certainly something that we are alive to. One thing that we are also looking at is like the regulatory landscape the different players that need to be involved across the value chain, and whether and how the regulatory landscape would need to evolve for hydrogen, whether hydrogen is genuinely included in things like the Gas Act and things like that. So there's quite a lot of thinking happening there, and the strategy will set out some of what we're planning to do there.
Okay, great. There's quite a few questions about things like the Net Zero Hydrogen Fund, which I'm guessing you've said what you can in the slides anyway, and it's a case of watch this space.
Yeah, so that, you know, there'll be some workshops happening in coming months. There'll be some consultation on that this year. So I think now that we had that confirmed in November, we're really ramping up to try and get a competition out, at least on a first tranche of funding, hopefully later this year. But it's a watch this space on that. There'll be quite a lot of industry engagement happening.
No, that's fine, thank you. And then just looking at you talked quite a bit about this anyway, but the hydrogen strategy and how it's being determined and who's involved. So obviously there's the council.
Yeah.
Is there anything else you can say about who's involved?
Well, so across government, we have various committees in place that are making what we really want to do, because there's a number of sectoral strategies happening. So there's going to be a heat and building strategy, there's the transport decarbonisation plan, there's the industrial decarbonisation strategy. Each of those are going to have some elements of hydrogen within it, and the energy white paper talks about it. We will bring those things together and talk about them in a bit more detail. So in order to do that, we have to have internal committees that are bringing together all of our policy officials. And then we've got the Hydrogen Council, we've got those working groups. They will certainly be informing some of that. We also had such an enormous amount of interest for the working groups on the councils, which we, you know, even in this world of working remotely, we didn't want to have kind of 50 people on the working groups. So we're sort of holding on to that interest by having what we're calling focus groups, where every now and again we'll be having larger meetings where we can do some transmitting and getting some feedback, so that we are trying to talk to the widest group possible. But, you know, that strategy is a point in time. It's not going to be the whole answer. There'll be some areas where we'll go into quite a bit of detail about our thinking, but other areas where we'll say this is an area we think is important and we're going to consider it going forward, and we will do engagement to support that as we go.
Great, thank you. Yeah, and I think we can echo the interest. As you know, we had, I think it was close to 600 people signed up.
Yes.
And we've got about 400 live on just now. So just, I guess just trying to pick out one final one. There's obviously a lot in here. I think people feel that there's a question around the funding landscape and the support landscape being slightly blurred. A lot going on. Is there work going on to simplify it, I think is what we're trying to do.
So I think we recognise that it can be difficult to navigate the landscape, and as that is something that we are alive to, particularly when we're developing new funds, we want to make sure that we are thinking about the timing and the criteria in a way that are complementary. And I think there are some areas where we're looking at whether we could kind of rationalise the way that people get, you know, sort of, is there a way that we could use portals and things for groups of funds where you would be directed a bit more easily to them, because it's sort of the nature of the way that we bid for things and the way that money is allocated to us kind of does divide things up, but we are conscious that it is part of a wider landscape and very much trying to make sure that we reflect that. And one of the things that was announced in the 10-point plan was super places. And that is something that the number 10 are really interested in, which is about how we make sure that the different funding pots that are happening in places are greater than some of their parts, and how we can make it easier for funds to interact with each other and with the local landscape to ensure that you're really maximising the delivery that's happening. Because sometimes I think we would all be aware that it's a little bit more difficult than it should be. So I'm not saying it's going to be perfect, but it's certainly something that we are alive to.
Great, brilliant, yeah. And I suppose hopefully the network can help with that as well. That's
yeah, certainly
interacting. Okay, I think we're going to stop it there because we're going to overrun. Thank you very much for your time.
Thank you very much. Thank you.
And we'll move it on. So Simon, are you okay to go to next slide, which is our Mentimeter?
Yeah, so thank you very much, Steph. So we've got a lot of experts on here today. We've got 370 people who are attending, so thank you very much for joining in. You've asked some questions. It's now our turn to ask some questions of you. If you could go to www.menti.com and enter the code 2202727. Please do this if you can on another device, so you don't have to log out and log back in to Zoom. And so I'll stop sharing now. And Shelley, if you can share Menti, please. So thank you very much. So first question, and we're already getting a load of answers in here. How does your experience of UK hydrogen innovation support compare with that available in other countries?
Yeah, so it's just worth saying, so this, as you can see, this is live. I'm not sure if you're familiar with Menti and used it before, but so I've just seen somebody say, what's the code again? It's actually at the top of the screen there, so starts in 22. This is live. We'll capture these results. We get a summary, and it may be that we can circulate something at a later date as well. So very well, there's a lot of no ideas. I think there's definitely a theme of too soon, not sure just yet. Interesting, the one about the EU seeming to be clearer than the UK, so and Germany and the Netherlands as well. A few more coming through. They're quick out of the starting blocks, aren't they? Okay, shall we move on to the, yeah, clearly a theme of we're not quite sure, and we'd like it to be a bit clearer. Shall we move on?
The next question, please, Shelley. So what are the main barriers to commercialization and uptake at scale in your organization? So that, again, the code is 2202727.
That's quite, those first two were quite interesting there, because they're kind of opposite ends of the spectrum. So UK policy, but then end users of hydrogen, which hopefully will fit with what we talk about with the network later on. Obviously cost is an issue there, and funding. Hydrogen as a tradable commodity is an interesting one. So I guess we're saying that we kind of, it's a chicken and egg, isn't it? We need it to be there, tradable, to be able to use it and have the market there. Senior management, so I guess someone with a background in industry. I guess that's the buy-in to treat hydrogen as any other fuel or energy vector, energy source. Supply chain. Okay, should we move on?
Yes, if we can go to the next one, Shelley. But please keep putting your answers in, because as Steph said, we will take all this information and we will share it with our stakeholders, so your voice won't be lost. What are the most pressing research challenges that could unlock the potential for hydrogen now in the long and short term? And again, the code is 2202727.
Storage is far and away features the most highly in those first ones, and scaling. Retrofit's an interesting one, and I know probably Matt will have some things to say about that, you know, when we've got sort of rolling stock or vehicles that might be in service for 20, 30, 40 years. And integration, yeah, definitely. I think definitely if this was picking out, you know, if words were sized based on the number, storage would be up there at the top. Yeah. Thanks for your participation. This is great. It's always tricky when you've got a live webinar to get everybody involved. Okay, I think we've
really
got
good
one.
figures here, really good numbers coming back in. So keep going. So if we go to next question, please.
And I think this is the final one as well.
So what actions in 2021 would help the UK to develop the most effective ways to develop internationally competitive UK supply chains?
Funding. Education, completely agree. I mean, that was one thing that came through. We didn't get a chance to ask Rita, but about that sort of what part do the government play in educating the public? Yeah. And funding for scale. Yeah. European collaboration, definitely key there, and echoes what people said on the first slide, that in the EU sometimes they seem to be a bit clearer on the hydrogen role. Okay, I think that's our last one. I think in the interest of time, Simon, we'll probably move on, shall we? But thank you very much for that. As I say, it's kind of always hard we've got something like close to 400 people online just now, so it's always hard to get that interaction, but that will remain live for a little bit, so feel free to add your questions in there now. Okay, so we go on to the next slide, and I'm pleased to welcome Rebecca from EDF Energy, talking about Hive for Fleets. Good morning.
Good morning, everybody. So thank you for inviting me to speak today. So my name is Rebecca Rosling. I'm head of the Smart Customers team within R&D and EDF in the UK. If you can move to the next slide, please, Steffan. So there's a lot of people on the call, so I won't assume that everyone knows who EDF are. So we're Britain's largest producer of low carbon electricity, and we're also a very large supplier. Our company purpose that we reissued last year is to help Britain achieve net zero. So really everything that we're doing now is focused around supporting the net zero transition, obviously particularly in energy markets. Next slide. So this gives a little bit of a flavour of EDF and all the different areas that we're involved in. So this kind of pack of cards shows that we're basically involved in generation. So we operate a large fleet of nuclear plant, and also one CCGT and one coal station that's approaching the end of its life. We're also constructing a new nuclear power station at Hinkley Point C. We're developing other kind of new nuclear stations, but we also have a very big renewables business that is developing, building and operating renewable generation, and also batteries. They just acquired Pivot Power, who are a large battery developer. And on the customer end of the spectrum, we have an energy services branch called Imtech. We're very, very focused on electric mobility. It's a really large area of focus for us at the moment, and also are a supplier trying to develop innovative low carbon solutions for our customers. And that's any customer from a residential to the largest industrial and commercial customers. And I think the reason I showed this slide is not just to kind of introduce EDF, but also I work in the R&D, which kind of sits in the middle of all of that. And I've talked to people in every one of those divisions in the last few months about hydrogen. It's absolutely going to, it's got a role in every single part of our business, whether it be co-locating electrolyzers with renewable or nuclear assets, or looking at some of our old generation sites and whether they could become hydrogen hubs, or also producing solutions for customers. To that end, EDF, and this is actually in France, so we have a French parent, Électricité de France, have launched a dedicated hydrogen subsidiary a couple of years ago. If you move to the next slide, called Hynamics, that are focused on end-to-end electrolytic hydrogen. So they're across that whole value chain, from producing the electricity from low carbon, so producing the hydrogen from low carbon electricity, storage, distribution, and then end users. So that's my introduction. I guess the main thing really that I want to talk about today is one specific project that we're doing in my team to support the hydrogen transition, particularly on transport. So if you move to the next slide, Steffan. So it's called High for Fleets. It's a 6-month project funded by Innovate UK. It's actually, I don't think it is one of the things that the initiatives that Rita showed on her funding landscape slide, because it was from a funding call on zero emissions vehicles in general rather than a hydrogen specific funding call. So so it's 50% funded by Innovate UK and also supported by our nuclear projects. So the idea is that we would try and address the gap in technical and economic insights on hydrogen switching by coming up with an assessment tool that will evaluate the kind of operational, economic and environmental performance of a hydrogen fleet. So that's either buses or trucks in the real world. So what this is doing is it's building on a tool that we've already got that helps fleet managers understand what their capability is of switching their fleet to electric vehicles. So this is fleets of small scale vehicles. So we thought what would be useful is to take that EV switching tool and turn it into a hydrogen switching tool. So the two main deliverables, one is a kind of feasibility study report, so showing how possible it is to come up with these recommendations, and then also a prototype tool that we can try for different use cases. So if we move to the next slide, that gives a bit of an overview of what the tool is. So what it does is it takes in both the main inputs are fleet profile information. So that's what kind of vehicles have you got? Have you got 100 small trucks? Have you got 12 big trucks? What kind of buses have you got? So really kind of high level information about the vehicles. And it combines that with GPS data. So it, or where it's available, it's not always available, but by and large GPS data, and tries to understand what are the general patterns, what do those vehicles do every day. It then outputs various things, which I'll go into in a little bit more detail, but one is a recommendation on what a suitable hydrogen replacement for your diesel vehicles might be. It gives you some information about what kind of refueling patterns there would be for those vehicles, and therefore what infrastructure you'd need. It tells you about what your total hydrogen demand would be for switching your fleet to hydrogen, and gives you a little bit of information on the environmental impact of that switch, and also the total cost of ownership. So if you move to the next slide, thank you. So don't worry, I'm not going to go through that equation in too much detail, but this is broadly what it does to calculate the energy consumption profile. So it starts off with some information about a vehicle and about the impact of driving patterns on the consumption of that vehicle. So as we all know, you consume more fuel if you're maybe stopping and starting a lot, or if you're going at different speeds. So it kind of so by using GPS data, it tells you what your kind of consumption would be. It obviously combines that with different vehicle types. So, you know, what are the characteristics of the vehicles that we're using? And then, as I said, it takes the reference driving cycle, which will either come from GPS data where that's available, or if it's not available for whatever reason, we can make some, you know, assumptions or estimates. So what that tells us then is what is for the bus or the HGV that we're looking at, what are the estimates of the hydrogen fuel mileage that bus or truck would need. And if you move to the next slide, so this is some of the outputs, I suppose, of the model. So the first graph at the top left shows a fairly typical kind of amount of hydrogen in the tank graph. So as you see, you kind of refuel at the beginning of the day in this case, and then it kind of gradually runs down and then it refuels. So that's fairly self-explanatory. And then we also kind of combine that with we kind of aggregate that up into daily, hourly or monthly views, and it shows you what your overall fleet patterns are. So if you look at that, so the main use case that we've got for this so far is the construction project at Hinkley Point C, which is a very, very large construction project for a new nuclear station. So I think what you can see from the graph at the bottom left is this is for the bus fleet there, which is, as you know, there's so many people on site, it's a pretty sizable bus fleet. So, you know, you get those peaks at the beginning of the day and the end of the day at the shift handovers at 7. And the reason we're using Hinkley Point C for our main use case is that we want to use this tool to understand. One of the main use cases will be if EDF gets permission to build a replica of Hinkley Point C at Sizewell C, we want to make that a low carbon construction site. So by using the data from the Hinkley site, which is already underway, we want to see whether we can use hydrogen to fuel a lot of the buses and HGVs at Sizewell C. So the idea is then that we kind of repeat this across the fleet and come up with an idea, a good indication of what the patterns are across the fleet. And then on the environmental impact, so what this shows is it breaks down the environmental impact of your fleet, comparing a hydrogen bus to a diesel bus or an HGV. And I think the important point here is that it includes both the vehicle production, which is the orange blob, with the ongoing emissions through the operation of the vehicle. So I think what you can see is, as you might expect, the diesel vehicles produce a lot more emissions than the hydrogen vehicles, which is obviously no surprise to anybody. And at production, so that there is slightly higher emissions through the production, the build, the capex, the upfront building of the vehicles for hydrogen vehicles than ICE. But I think it's important to kind of note that it's a relatively new technology, so I don't think we should necessarily assume that will be the case forever. The reason that there's still some blue in the hydrogen is that we're taking being pretty conservative, I suppose, in what the emissions involved with the production of the hydrogen is. And then I think that the graph on the right, which I won't go through because I think we're already over time, shows breaks down the upfront emissions into different parts of the kind of production of the vehicle. And then finally, if I move to the total cost of own, okay. Sorry, it's not on there, but I think that's the main thing that I wanted to cover today. I don't know whether we've got any time for questions, but obviously my details will be available if anyone wants to discuss this further. We have got a few use cases, but we're really always interested in working with any other fleet managers who'd be interested in applying this to their fleet as a kind of partnership together.
Thank you very much, Rebecca, and amazing timekeeping, considering I think we started you off a little bit late, but brilliant. We'll save questions if that's okay, and then if we get time at the end, we'll come to some at the end. So thank you very much. So without further ado, let's move straight on to Julian from Zero Avia.
Hi, thank you. Thanks for everyone for showing up. I think we're still almost 400 people joining. It's great to speak to every one of you as part of this Hydrogen Innovation Network launch. And I'll tell you about one of the use cases of hydrogen, and one that we, of course, think is kind of like the most promising one over the coming years, which is aviation. And we at Zero Avia, we aim to be the most practical zero-emission aviation company. What I'll do in the next 10 minutes or so is actually tell you how we are that practical and why we think that is particularly important, because we act in the hydrogen economy, which historically has always had that little bit of a chicken and egg problem, right? So we'll talk a little bit about that, how we are thinking about it. Now, on the first slide, just quickly, if we move there, you will see the basic problem in a slightly misformatted way. But the core idea is, right, that in the aviation industry, it is one of the hardest to decarbonize sectors, simply because you need a very energy dense substance to lift an aircraft off the ground. You need a lot of power and you need a lot of energy. So that's why burning jet fuel is, to this date, the only alternative you have. And the only solution we do have at the moment is actually moving to biofuels or to synthetic fuels, which is something that, as you can see here in this little chart that shows you what's predicted to happen, it shows you that really kind of the solutions we have today are not sufficient. And they are also not really scalable. And that leads you to a problem, because we are in aviation today at a climate impact from somewhere between 5 to 10% of the total human climate impact. And people see that rise to something like 25 to 50% by 2050, which leads to the question, you know, does aviation still have a future? Like, is there a social license to actually operate? And we, of course, think there needs to be a solution. And we, of course, think we're developing that one. And the vision that we do have is, if you move to the next slide, is renewably powered hydrogen electric aviation. What you see here is essentially the ecosystem that we are developing, leading towards a long range, lower cost and zero emission solution. And what is really important, and coming back to my first slide about being practical in this, is we cannot do everything in this picture, right? What we focus on at ZeroAvia is developing the propulsion system solution. So everything you see on the right-hand side inside the wing of the aircraft, from onboard storage of hydrogen on the aircraft, putting that into a fuel cell, combining that with oxygen from the air, turning it into electricity, and then spinning electric motors that in turn spin a propeller, a fan, whatever you want to spin, depending on the size of the aircraft. Of course, all that only is a zero emission solution if you produce the hydrogen in a zero emission manner. And that's again where we think aviation is a particularly interesting use case, because aviation is an incredibly large user of hydrogen, potentially, with every single vehicle. And every single vehicle operates a long time throughout the day, because essentially every moment that the airplane does not fly, is not in the air, does not bring money to airlines. So airlines really stress utilization of the aircraft. And each single flight, even on a 20-seat aircraft, which is really the very, very small end, already consumes something like 100 kilos of hydrogen, which is about, 5x compared to buses. It's probably 20x compared to cars. And that really gives you scale at airports initially, that you can actually do hydrogen production on site, which really helps you with the economics. Now, let's think about what we actually need to do to get there. One of the most interesting things that we have seen, especially over the last 6, 7, 8 months, is really a lot of the momentum accelerating. So if we move to the next slide, I think what we can say is that, what we can by now say justly, is that hydrogen is really considered the fuel of choice if you really want to decarbonize aviation. It started about a year ago in May 2020 with that study that the Hydrogen Fuel Cell Joint Undertaking conducted together with McKinsey and Clean Sky, that talked about the potential of hydrogen in aviation. Continued with Airbus announcing hydrogen-powered aircraft concepts in September last year. And by now, there were even total covers of one of the most popular aviation industry magazines that you see on the right, that actually promoted hydrogen in the industry. But of course, we as a startup, we believe there is really only one way of doing this in a more meaningful way. And that means you have to actually show some steps on this journey already now, and not only talk about 2035 as Airbus does. We need to have a credible plan on how to scale from what we can do today to something the size of what Airbus is showing here. And lastly is we need to build the support system and the ecosystem around it. And now let's walk through each of these 3 stages. If we go to the next slide. We think if you want to be really practical about decarbonizing aviation, you need to show people what it actually means. And so that is why our first step was flying the 60 aircraft out of Cranfield in September last year. And that is the largest hydrogen electric aircraft in the world, and it is flying constantly since then. We're just kicking off another phase of flight testing now towards the end of this month, and then will in February conduct long distance flying as well, including the first A to B hydrogen electric flights ever. So watch out in the skies around Cranfield if you live anywhere close. that will be coming up very shortly. And that is really exciting, right? It shows people what's possible. And if you move to the next slide, it is not only the aircraft technology that we are showing, and I really apologize for the formatting of the slides, by the way. I'll make sure to send a proper version to Steffan afterwards. We also show that actually the on-site ecosystem of the hydrogen production, generation, storage, and fueling actually works. So we have on-site renewables, we have on-site electrolysis, we have our mobile fueling unit that you see there on the top right. And then we have, you know, a hydrogen car as well, but of course we have the aircraft actually using it. And that we think is really exciting when you think about, you know, what should be these initial hydrogen deployment locations. Well, airports are actually great use cases. Aviation itself is one big off-taker. And then you have a lot of travel from and to airports that could also be using that hydrogen that you produce there. So that's what we're doing today. Now let's have a quick look at what we're doing next. If you could go to the next slide. What we're doing next is we're moving from the 6-seater to actually our first commercial offering, which will be in the 9 to 19 seat category or 10 to 20 seat category, covering 500-mile range, which is about 50% of trips worldwide. And we just announced actually in the end of December funding from the UK government as part of the ATI program to support that development, to support the R&D for the 19-seater. And then you will see that 19-seater flying by the end of this year. And by 2023, we expect to have it commercially available, certified on the market for you to actually have your first zero emission flights. So that we're really looking forward to. The great thing with hydrogen, though, is that it does not end with a 19-seater. It can actually then scale to the regional turboprops that you see here with 2027. It can even scale to the small narrow body markets like the A320, which you've seen announced by Airbus as well in the 2030, 2035 timeline. So that's our roadmap. And then the last thing I promised you to talk about is the support ecosystem that you need. And what you see here is the set of investors that we did announce in the end of last year as well. So we're backed by Amazon Climate Fund. We're backed by Breakthrough Energy Ventures, which is Bill Gates' venture fund. And that is really important as well, right? Because we always talk about, you know, supply chain needs to develop, you know, we need to get the hydrogen ecosystem ready, but we also need to bring really capital into the sector. And with these kind of backers now, you know, there is actually a road for us to certify those systems, to get them out in the market and to build out supply chain on all sides that we need to do. And of course, one of the backers that we do have, and that's my final slide, is the UK government through the High Flyer 1 program, through the High Flyer 2 program, and sitting on the Jet Zero Council. Of course, the ambition is to have a zero emission jet by 2030, and that's what we are really striving towards. And that's my final words. Just want to say thank you again and look forward to any questions you are having in a few minutes. Hopefully we have some time for that. Thanks, Steffan.
That's great. Thank you, Julian. And yeah, as you say, we're not doing badly on time. So thank you for being prompt as well. And we'll definitely try and at least have a question for each of you right at the very end. So again, I'm just going to not waste time talking myself and just ask Simon to move us on to Matt from Steamology.
Great. Thank you for the opportunity. It's great to be here. I'll try and fly through these slides. My name is Matt Candy. I'd like to introduce you to Steamology. Next slide, please. We are a 10-person startup. We're pre-revenue. We've got our own CAD, CNC, CFD and test facilities, all based near Salisbury. In the next slide, you can see the journey started over 10 years ago. We broke the land speed record for a steam-powered car. And this gave us experience in high temperature, high pressure steam. It was a turbine mechanically driven at the wheels. It had a nod to eco. It was LPG fired. And although advanced design, it was a traditional flash boiler. We broke the record and still hold the record, but we didn't really smash the record. Next slide, please. And this led to thinking about how to do it better. At the core of everything we do at Steamology is the combustion of hydrogen and oxygen. And if you burn hydrogen and oxygen, you only get hot steam. You get no NOx, no SOx, no CO2, no particulate. The only byproduct of combustion is water. So you can transform water into power. And in 2014, the journey started to build a faster car. And very sadly, the sponsor of the project was killed in a helicopter accident in 2018. And there's an expression, if you want to make a small fortune in land speed, you should start with a large one. So next slide, please. We needed to look for commercial applications. And the overall picture for our water-to-water cycle is that we know that renewable energy is abundant. 10,000 times more sun hits the world every day than we use. It's just in the wrong place at the wrong time. So we can use renewables to power electrolysis and create hydrogen and oxygen gas. And by storing the gas, it's the battery of our system. So when the sun has gone down or the wind stops blowing, we can burn the gas, create steam, and in this case, drive a turbine to make electricity and return the water back round to the electrolysis process. So we've got an overall effective energy cycle. Next slide, please. We've got three major product groups sharing common technology. The first is gas to steam. So we can take stored gas and quickly, within seconds, we can make a high quality and a high quantity of steam. And we're exploring pure steam for pharmaceutical processes, industrial steam from distilleries through to tea plantations. And in the next slide, we can also create high temperature saturated steam for thermal oil circuits through a heat exchanger for the chemical industry looking to reduce their Scope 1 emissions. So that's the first product group. The next slide, please. The next one is gas to power. So we brew our steam typically at 40 bar, 400 degrees C for this application. 40 bar is chosen because you can hold it in standard materials, and 400 degrees C, again, we use a lot of aluminium. So we're not using fancy exotic materials or processes. We want to have a cradle to cradle approach, full recyclability, kind to water, no toxic materials. We can make scalable, quiet, zero emission turbines to output mechanical, electrical, or hydraulic power. Next slide, please. And this has led us, particularly in high power applications, to explore rail and marine, where the decarbonisation agenda is very strong. But we're also keen to look at heavy haulage and construction, but also static power. We can come into power and off power very quickly. So in a ULEZ zone, we could provide charging for vehicles or loads for hotels, data centers, this sort of thing. Next slide, please. The third product group is renewable energy storage and power. So this is combining our activities, and we're looking to partner with electrolysis experts, gas compression and storage to develop storage and power projects. So that's an overview of our three product groups and the projects we've got. Next slide, please. We're working with Strathmore University in Nairobi, Kenya, and this is to develop an off-grid storage and generation facility. And in the next slide, we're developing for microgrids in a 20-foot ISO container, electrolysis, gas storage and compression, and electrical generation. This is a pilot project that will be deployed later this year. Next slide, please. In the rail industry, we've got a number of approaches, and the first one that we did last year in 2019 was a 100 kilowatt range extender. And this allowed us to explore the idea of taking gas in and creating 750 volt DC for the traction motors or for the batteries. Working with Viva Rail, who are retractioning the old London Underground District Line stock, this is a flexible power module. Next slide, please. We have an advantage, about 250, 300 kilowatts. We occupy the same space as a diesel engine. And so we've got, whether it's a mechanical output or electromechanical output, and what becomes interesting is that with batteries and fuel cells, it's very linear. Every time you add 100 kilowatts, you add a block and a balance of plant, whereas we just add more steam generators to the same turbine. So we have an energy density at higher power output, which is where we feel we have more of an advantage. And we can use a wide range of fuel purities, which gives us an advantage. And the space liberated allows us to store the oxygen that we also need. Next slide, please. So we're also looking at high power applications in steam electric. So we have a low carbon rail freight project where we're doing a 600 kilowatt turbine for demonstration at the end of March. And this will power a permanent magnet motor and supply electricity for traction motors to retraction existing rail freight or be part of full power or bi-mode power on new rolling stock. Next slide, please. So with the freight, you've got 74 foot, 125 tons, 14.5 tons of diesel to come out. So we're looking at the implications of retractioning the whole kit. Next slide, please. And this is allowing us to develop the steam generators. So steam generators got no moving parts. You get to steam in seconds. So we've got the torque response, the throttle response required for simulating a diesel. And it's very spanner friendly for maintenance. Next slide, please. We've got a very simple turbine reduction gearbox. So this is mechanical. The turbine spins at 9,000 RPM, and we can come down to generator or diesel gearbox speeds. So it's a very simple, long life, fully recyclable approach. Next slide, please. Towards the end of March, you're very welcome to come and see us demonstrating on the dynamometer. We're in build, and we'll be doing a public demonstration of the 600 kilowatt turbine running through this kit. Next slide, please. Energy density is always a problem. So with freight trains, battery and fuel cell solutions often require a tender, which takes up weight, length, space, charging time. So we're looking at a single box solution. We can get about 13 megawatt hours of useful power in a freight format, which compares to about 20 megawatt hours that you might find in a diesel. So we're not there, but we're getting close. Next slide, please. Interestingly, we can do direct drive as well. So this is a live project where we've got a turbine going through a traditional ZF EcoWorld box. Next slide. And this is retractioning traditional DMU. So there's 3,700 DMUs on the network, 2035 in Scotland, 2040 UK. These have to come off, no diesels on the UK network after that. So we're looking at unbolt the diesel and put our solution on as a power solution for that. And this is showing that we can get the range and we can get the power and we can do it all under the floor. Next slide, please. So this power unit, we're very interested to engage in the wider community. This is a 300 kilowatt power unit. It's flexible. It's a closed cycle. It can use a wide variety of fuel purities. So we can look at heavy haulage, construction and marine wider markets for this. So we really welcome a wider conversation. Next slide, please. So thank you very much. It's a whistle-stop tour of what we're doing. Really welcome to engage. My name is Matt Candy, and together let's make green power make a difference. Thank you.
Great, thanks, Matt. Judging by the questions coming in, people are very interested. We are getting quite tight for time, folks, so we'll move on to Nopi and we'll do our best with questions at the end. Worst case scenario, it may be that we end up sending out a Q&A document once the speakers have had a chance to respond to a few things afterwards. So anyway, I won't hold you up. I've got a really interesting chat now from Nopi about British Antarctic Survey. Hi, Nopi.
Hi, thank you, Steffan, and thank you for inviting us to this launch event. So my name is Nopi Exizidou. I'm the Energy and Carbon Reduction Manager at the British Antarctic Survey. I lead the effort of decarbonizing our operations, focusing mainly on infrastructure, transport and logistics, and supply chain. And during this brief talk, I'm going to go through our net zero carbon commitments, our decarbonization challenges. I'm going to mention potential solutions and technologies that we are looking at. And also, I'm going to look at the opportunities of using hydrogen just to solve some of our large, big decarbonization challenges that we have as a remote community. Simon, can you, next slide, please? Thank you. So we operate on the coldest, windiest, driest, highest place on Earth. We have 3 stations in Antarctica, 2 stations in the subantarctic islands of South Georgia, 1 in the Arctic, and our headquarters in Cambridge. Next slide, please. So how do we get there? We have our ships, so we operate our ships at the moment, the James Clark Ross, which is soon to be replaced by our new research vessel, the Sir David Attenborough. So we use the ships to transfer people, so scientists, science support staff, their equipment, food, fuel, and everything we need to operate a station in Antarctica and to deliver our science. The ships are also doing science cruises as well. We usually fly to the gateways of Antarctica. So these are at the tip of South America, the Falkland Islands, and Cape Town in Africa. And then from there, we use our own aircraft or ship to reach the stations. We also have a fleet of aircraft, so 5 aircraft that help us not only get to Antarctica, but also go deep into the field to support our science delivery. Now, as you see, the operation of ships and aircraft is basically the largest part of our carbon footprint and very difficult areas to decarbonize. Next slide. BEIS is committed to achieve net zero carbon emissions by 2040. And this is looking at our own operations, but also some high impact measurable scope 3 emissions. It's worth mentioning here that the British Antarctic Survey is part of the Natural Environment Research Council, which is part of UK Research and Innovation. So we are fully aligned with the sustainability, the environmental sustainability strategy of UKRI, and also the aspirations of NEC. But most importantly for us as an environmental organization and climate expert organization is to contribute to the global efforts of climate change mitigation. Our focus areas are our directly managed activities, so the ones that we have full control of, and I'm talking about our infrastructure, our estate, our ships and aircraft. But we are also looking at our outsource activities, the ones that we have indirect control of through our financial decisions, such as procurement and all of the contracted activities. And then wider investments and research collaborations where we can have indirect influence of the activities of others. Next slide, please. Our net zero carbon strategy has 5 focus areas. So science is our main driver for everything we do. We need to understand how to deliver science in a net zero future, and how can we contribute to global mitigation strategies through our science. Regarding our infrastructure, we have set very ambitious target for decarbonizing our estate, both in Antarctica and in Cambridge by 2030. This is a very challenging task. However, there are technological advancements that can actually help us deliver such an ambitious target. Whereas in transport and logistics, as I already said, we operate ships, aircraft, and large vehicles that take us thousands of miles deep into the field in Antarctica. And this is very challenging areas to decarbonize. However, we do focus on the opportunities and on the improvements that we can make, looking at operational efficiency, optimized fuel use, reducing demand, but also looking at sustainable biofuels and hydrogen as a technology that we could use in the future to decarbonize these areas. Regarding our supply chain, we work together with our suppliers to develop shared values and common values and goals around sustainability. It's important to understand the whole impact of our supply chain to our carbon footprint here. And then as part of our community, which is really important, we aim to create partnerships with the industry and academia, not only as a way to help us deliver our decarbonization targets, but also to help with the uptake of low carbon technologies. Next slide, please. We are facing a lot of challenges because of where we operate. A lot of them are around energy. So every energy system that we have on station needs to be reliable and robust because they provide life support. And it also supports the operation of scientific equipment. So everything needs to have a backup, and the backup systems are relying on diesel. A lot of environmental challenges, so extreme weather conditions such as strong gusty winds, ice formation, which affects the operation of renewable energy systems such as wind turbines, and also limited solar radiation potential because we only have solar energy for half of the year or for very limited time, depending on where we are on the continent. A lot of our challenges are also regarding new technology. So we need to assess the risks of introducing new technology to stations. We operate in very rich and sensitive wildlife environments, and we need to mitigate those risks for every new technology that we apply on station. A lot of our technological challenges are around aviation and shipping, as I already said. Ships that are being built today do rely on fossil fuel. And then the last one that I'm mentioning here is that we need to have multi-skilled technical staff on station that will be able to support the operation of such a large variety of systems that we have there. Next slide, please. As an example, this is our Bird Island Research Station in South Georgia. This is a very remote station. It's only approachable by ship. It has a lot of challenges around new technology application. So as the name says, we have a lot of birds around, so albatrosses, nesting penguins, seals, and different species of birds. So this poses risks for example, conventional wind turbines are difficult to be implemented here. And also the area, the local climate is characterized by a lot of rain. So solar radiation and the use of solar photovoltaics can give us limited generation potential. So we used Bird Island and Sydney. Simon, next slide, please. As an example for the KTN Innovation Exchange challenges that we ran in November. So the first challenge was how can we decarbonize the energy supply of such remote places? And then the second one was how can we decarbonize the fuel system for polar vehicles in remote logistic facilities? And we received quite interesting technological solutions as proposals. A lot of them are going to inform our decarbonization strategy for these areas and is going to help us reach our targets in the future. To mention a few, combined heat and power with vertical axis wind turbines, alternative fuels, tidal power, heat generation from wind energy, seawater heat pumps. So these are going to inform the decision making for our decarbonization strategy for these areas. Next slide, please. And hydrogen can actually be a solution to our biggest decarbonization challenges. It does present great opportunities, especially for hard to decarbonize sectors such as long-haul transport, heavy industry, and also for long-term energy storage. Some of the challenges are have already been mentioned. such as storage and high costs, and the need for a robust regulatory framework. But as an environmental organization, I would like to mention here that we also need to understand the environmental impact of using hydrogen in large-scale applications. So we need to understand what the impact is going to be so that we don't create new environmental challenges in an effort to solve the existing environmental challenges. Rebecca has touched on the environmental impact of using hydrogen in vehicles, but we need to see the larger picture in all areas that we're planning to use hydrogen as a technology. But for BEIS, for the British Antarctic Survey, hydrogen could be an important game changer. As I mentioned, we're having a new ship, the Sir David Attenborough, and we also operate a fleet of aircraft. So using hydrogen in shipping and aviation could be an important change and an important factor to decarbonize these areas. But also looking at the energy provision of some of the remote stations that we have in Antarctica, where conventional renewable energy systems are not feasible or present a lot of challenges. And that will be all for me. Thank you very much.
That's great. Thank you, Nopi. I think everyone will agree that that was a really interesting, different angle, different viewpoint to look at from hydrogen. Thank you very much. Okay, so that's all from our speakers that were able to join us. So I hope you found that really interesting. Just great to hear about the work that's going on and sharing the unique challenges that everybody's presented with. I'm just going to explain quickly about what the Innovation Network's all about, really, and frankly, why you ought to get involved. So next slide, please, Simon. So, I mean, to be honest, I'm hoping that everything that's gone before me has presented the context, really. But you know, just a reminder that, as Rita said right at the start, it's a hot topic at the moment. These are actually both these sources are from the Climate Change Committee, but just feature both in their own 6th carbon budget and also in the energy white paper recently. But I think the point is, it's just hydrogen is seen, whatever scenario going forwards, hydrogen is seen as playing a key role. Next slide, please. And quite simply across most sectors, which we're going to come on to, and it's influenced our thought as to what role the network can play. But again, I think the point is that pretty much any sector you look at, hydrogen will play a key part in. Not the only part, so we're not in any way saying it's the only solution, it's not, but it'll definitely be part of that balanced net zero pathway as the CCC talk about. Okay, next slide, please, Simon. And we've heard already about the 10-point plan from Rita and a couple of our other speakers. I mean, we all knew hydrogen would feature on that, but I think the point that it was number 2, it was right up there, shows how important it is on the ministerial table, and in transport as well. So, things going forwards as well, there's lots coming out this year that will feature this. I mean, Rita alluded to a few things from BEIS, but from DFT, I think the transport decarbonisation plans put back to spring, but it's widely acknowledged that hydrogen will feature strongly as part of that. So yeah, next slide, please, Simon. So hydrogen's key. It's a hot topic at the moment. We've peaked at about 400 people online today who all want to know, probably they want to know a lot about what Rita and BEIS are planning coming forwards. But the point is, there's a huge amount of interest, and it's this hot topic we talk about. However, I'm sure we're all agreed that the landscape is very complex. So there's lots of work going on, whether that's government, UKRI, private sector. Rita's talked about the advisory council, which seems a while ago now. That kicked off in the summer last year. And what we want to do is make sure that this network adds value through a combination of discussions, including a very small pre-launch workshop we had with about 15 people in mid-November. I think what we heard was sort of echoed by what we've heard today, really, which is that BEIS, Innovate UK as well, are doing a lot around the production side. Whether that be, like Rita says, there's a need just to get the scale out there, get the volume out there, but also, you know, moving forwards into green or clean hydrogen. But as we've spoken to a lot of people, be those end users or people like the Scottish and Hydrogen Fuel Cell Association, UK Hydrogen Fuel Cell Association, better not forget HyCamRoo, there's this chicken and egg about production or end use need. And as there's a lot of focus on the production side, we see that where KTN and this network can really add value. Let's not forget this network is funded by Innovate UK, where we can add value rather than sitting in the same space as BEIS and Innovate is about that end use. So I think all of the people on the right hand side of this, highways, marine, aviation, will all have decarbonisation plans, 2050 plans, net zero plans. Hydrogen will feature highly in all of them. But I think what we're seeing when we speak to people is that we need support in unlocking what that actually looks like, putting people together and how we get that sort of end use and that uptake at scale. Okay, on to the next one, please, Simon. So I think just in a slide, without reading it word for word, the key here, the purpose of the network, the key is about this. What we want to do is help to validate views on the challenges to enabling clean, local clean hydrogen uptake, and finding innovative solutions to those challenges. So as I said, we've got this Innovate UK funding, which actually takes us right through into next year, so 2022. And yeah, we want to make sure, I mean, Rita said earlier on actually about, it's quite interesting about how we need the volume, and some of that might be blue, some of that might be green. I think we want to make sure that we've got the ability and the capacity to match that with clean hydrogen uptake and use with the end users. Okay, next slide, please, Simon. And so I suppose there's lots planned, but there's three key things we aim to focus on, and we've discussed this a lot with people like Innovate UK and Harsh Prashad and Rita's team in BEIS, and this workshop we had back in November. So I think firstly it's just capability. So, you know, for new entrants into this sector, what are the UK's strengths? What does the capability look like? And KTN have a landscape capability mapping way of doing that. So that'll be one of the first things we kick off with. What we then want to focus on is this viewpoint. So this validation of what the current challenges are, and crucially what's holding back deployment in these emerging markets and sectors, which then leads us on, and it wasn't by design, but Nopi nicely, one of her final slides talked about KTN Innovation Exchange, which has been very successful with a lot of people, including BEIS. But that's a way that we can go out to all sorts of different sectors and industries and look at what solutions there might be out there to some of these innovation challenges. So we want to use KTNIX to help with this network and with some of these challenges. So why sign up? Flick us on, thank you, Simon. So again, we could put a lot on here, but I think the key point that's come through in some of the questions today is what we want to do is help in understanding the landscape. Okay, we've, as you've heard, you know, just based on people signed up today, we had close to 600 people, 560 I think signed up. So all of those people will be brought on board into the network. So we've got those powerful connections. We will make sure that we use a newsletter bi-monthly, and crucially, you know, we've heard Rita talk about funding streams. There's probably some other stuff in the pipeline with Innovate. We'll make sure that we keep people up to date on those relevant funding streams through the newsletter and through other comms. And I think what KTN's really strong on is regional activity. So we want to make sure, we want to make sure we're close to SMEs and projects and case studies happening across UK regions. So again, we'll make sure that our members are kept up to date on that. We've mentioned about the capability map, so if you sign up, you'll get sight of that. And also, I'm not trying to do the KTN sales pitch, but as you saw right at the start with the video, KTN are very wide-reaching, and come on board with us, and obviously we will support you in whatever way we can. And finally, just to say about KTNIX, so again, I've already mentioned it, but it's a great opportunity at both ends. So for users or end users seeking solutions to those challenges, that's exactly what KTN is about. And also for people who hold solutions in whatever sector, it's a great opportunity to pitch and get them in front of the people that need them. Okay, so next steps, as I said, we'll get a capability map off the ground and out there to highlight weaknesses and emerging sectors. Very shortly, there'll be some workshops, and we will focus those per sector. So there'll almost certainly be an aviation workshop, a marine workshop, and it will be very focused on those end user challenges of getting clean hydrogen uptake at scale. So we will communicate about those. And again, watch this space for the Innovation Exchange to identify challenges upcoming. So I've literally got a couple of minutes left. Thanks, Simon, for keeping me on track with the slides. Just to be aware, I mean, there are a number of innovation networks funded by Innovate UK and run by KTN, but a couple of, frankly, almost sister networks that run. They're all run from within the Clean Energy and Infrastructure team. One is the Cross-Sector Battery Systems Innovation Network, run by my colleague Nicoletta, co-funded by the Faraday Battery Challenge, and it's all about cross-sector common user needs for battery systems, sort of outside of automotive. There's a link there, and there are some webinars starting tomorrow. So the first webinar is around batteries in defence tomorrow. You can go on our website to get that after the event. And then the other one is decarbonising ports and harbours. My colleague Mark Ray is heading this up. And what's really interesting about this is it's technology agnostic. So whether batteries, hydrogen, all of the above, they are looking for, the community are looking for reducing emissions on the land side activity of ports and harbours. So again, you'll see solutions maps, investment workshops, and an innovation exchange coming out there. Again, it's on our website if you want to follow that up afterwards. Next slide. Okay, finally, just a bit of shameless promotion. IETF, Industrial Energy Transformation Fund. The reason to mention these is there at the bottom. So this is open to hydrogen fuel switching projects, and I think not everybody realizes that. The top one, there's a spring window being added to the English version, England, Wales and Northern Ireland. That's open there, and there's a link there to some more information. Details will follow soon. And the Scottish variant, only open to Scottish sites, is open until the 26th of February. Contact Jenny for more details. Okay, conscious we're very tight on time. Final slide, please, Simon. I'm going to skip on to Q&A, skip through Q&A, and we will send a document out afterwards. Thank you for that. There's a sign up there. Join us there. If you go to that website, there's a link to sign up to the network. If you want to contact myself or my colleague Simon, who's done a great job in the background today, then please do so. But other than that, I'm afraid we've got this hard stop at 11:30, so I'm galloping through it. Thank you so much for joining us. We've got Meeting Mojo kicking off at 1, so do join in there, and I hope you found the networking opportunity valuable. Many thanks all.